Hi, this is Saka, and we're going to do the last half of the exam. So we're going to do 12 through 22 now. So for number 12, um, we have a new volume of the volume of 400 milliliters of chlorine gas, and at 400 millimeters of mercury is decreased to 200 milliliters at constant temperature. What is the new pressure? So here we have a V1 at 400 milliliters. We have a pressure that corresponds to 400 millimeters of mercury, and we have a V2 of 200 milliliters, and we're solving for P2. So with this one, remember it's P1 V1 equals P2 V2. So we just have to plug in our numbers and solve. For 13, um, which ones is an inverse relationship? Well, remember P and V is the only inverse relationship. So this is why this one would be A. And for 12, if you work that one out, I think it was D. For 14, according to Planck's law, pressure and temperature are directly related, which is another way of saying directly proportional. And so we know this one is Gay-Lussac's law, which is C. Uh, let's see. Let me make some more room so I can do 15. And I'll scroll it up a bit. 15. Determine the Celsius temperature. So we have 2.49, so N equals 2.49 moles. The volume is 1.00 liters, and the pressure is 143 kPa. Notice that you only have one set of conditions, so we're going to be using ideal gas flow, so PV equals nRT for this one. We have R is 0.0821. This is liters, atmospheres over moles times K. And so we have everything except the temperature. So we're going to solve for T. So if we just do a little algebra, divide both sides by NR. Cancel, cancel. We get PV over NR equals T. And so first thing we have to do is we have to convert our kPAs into atmosphere. So we multiply times 1 ATM over 101.3 kPa. Okay, so that gets us in atmospheres. Everything else is good to go. Remember, when we solve for our temperature, this temperature is going to be in K, and we want degrees Celsius, right? So remember, K equals degrees Celsius plus 273, right? So if we want Celsius, we're going to have to take our answer and subtract 273 before we look for the right answer here. I think for this one, the correct answer was C when we did it. Okay. Moving on to 16. Oops. Moving on to 16. So as pressure increases, the volume does what? So remember, PV equals P2 V2. So this is Boyle's law, right? And again, this is inversely proportional. So if the pressure increases, that means the volume decreases somehow. So that would mean C would be the right answer here. For 17, this one's kind of weird. There are several ways you can solve this, but the way this basically works is this. The easiest way is to probably just make a relationship. Pressure and volume and the amount of gas are basically going to be the same here because of this STP thing. So if you say 1.25 grams over 1.00 liters, you could say that's equal to X. Now because we have 1 mole of gas, we can say at STP the volume, remember the volume of any gas under standard temperature pressure conditions is 22.4 liters. So you can set the bottom at 22.4 liters, and you cross multiply and solve for X. Liters cancels. And I think for 17 you end up with something like E as your answer. 18, a sample of gas. So you want the molar mass of the gas here. So remember the molar mass is equal to I can't read my own writing, mRT over PV. And so now we just need to find all of our numbers. So M equals 0.686 grams. R is our constant, 0.0821. Liters times atmospheres over moles times K. T, sorry for writing all over, is 20 degrees Celsius plus 273 K, because you have to convert it to kelvins. Hi, Kai. My son's doing a temporary tattoo, so it looks good. I'll look at it in a second. Sorry. And the pressure is 722.5 millimeters of mercury. He threw me off. And we have to convert this to atmosphere, so 1 atm over 760 millimeters of mercury. And then the volume is 300. Oh my God, so bad. The volume, I'm running out of room. The volume is 350 milliliters. But remember, you have to convert it to liters. So 1 liter is equal to 1,000 milliliters. So you have to divide that by 1,000. You take all these numbers and you punch them into this equation. And for 18, you should have gotten C. Okay. I know it's messy, but hopefully you were able to follow that. Let me swipe it. Excuse me. And let me move on to 19. All right. With 19, it was... Mr. Lin was trying to be tricky here, and I think it just ended up... I don't know. Just me. So we have a piston under 621 milliliters of mercury is heated by 12.7 degrees. It doesn't mean it's at, it means it increased by 12.7 degrees. The piston now has a volume of 2.2 liters, while under 1.5 of atm of atmosphere of pressure. I can barely follow this myself. So we have, geez, so this is P2, so that's 621 millimeters of mercury, and the temperature T2 is T1 plus 12.7 degrees Celsius, and we'll get back to that in a second. And if the volume is 2.20 liters, hold on, I messed this up. Let me start over. He worded this so weird. Okay, so, oh my God, I can't follow this. Anyway, for this one, oh boy, so we have V1, P1, and T1. I hate when you're tricky just for the sake of being tricky. V2, P2, T2. All right, so the piston. All right, so this is. I still don't understand the question. All right, I'm gonna skip 19. I don't like it. 20. So here we're looking for grams of N2O gas, and so here we're gonna do PV equals nRT, and we're gonna solve for N. So we divide both sides by RT. So PV over RT equals N. Okay. So now we need to define what PV and RT are. So I'm going to erase because I'm making a mess here. And so go away. So I have my whiteboard at home, but okay, so back to the drawing board here. So we have a volume of 2.74 liters, a pressure of 114 kPa. We're going to have to convert that into atmospheres. The temperature is 41.1 degrees Celsius, which you're going to need to convert into Kelvin. And then we have our R. Remember, R is 0.0821 liters atmospheres over mole times K. And we go ahead and plug in our numbers and we solve. Now that is not the grams. What this is moles. So what you're going to have to do is you're going to have to convert. So you have to multiply, you have to convert your moles to grams. So you need the molar mass of N2O. So you have to look up the weight of N, multiply it times 2, and add it to O, and you're going to multiply it times your N. Just so you know, I didn't realize this till after second period, but the answers for 19 and 20 were reversed for whatever reason. So 19 was actually A, and 20 was actually C. I don't know what happened. So this should have been C. This should have been A. If you could figure out what the hell he was talking about. All right, for 21. For 21. Okay, this one you just had to know what STP is. Remember, STP conditions are the following for the billionth time. N is 1 mole. The volume for 1 mole of a gas under STP conditions is 22.4 liters. The temperature is 0 degrees Celsius or 273 K. The pressure is 1 atmosphere or 101.3 kPa or 760 millimeters of mercury or 760 torr or 14.7 psi. This is what standard temperature and pressure conditions are for a gas. You need to know all that stuff. Okay? And then for 22, the last one, which ones are not units of pressure? K is temperature. This is energy. And this one is frequency. So the rest of them, as I listed here, are all pressure units. So hopefully this will help you, and good luck studying tonight, guys.